Alright, Math 1, Unit 2, Lesson 9.2. So now we're doing geometric sequences. Remember, geometric sequences are repeated multiplication or division, though we tend to think more along the lines of multiplication. So the explicit formula for this one is a sub n equals a, the starting number, times b, the growth, to the x. Okay? So once again, we need that zero term, that starting number, and then our common ratio. Okay, so I suppose we should probably write this as our starting number would be a sub 0 times r to the x, if we're using the same terminology that they are. But we've done it this way before as well. Okay, so what we need to do is the first thing we need to do is find the zero term and then the ratio. So first term, second, third, fourth, we'll need to go back to the zero term. So 1 to 2, 2 to 4, 4 to 8. Since we're multiplying, the only number we can multiply by is 2. So our common constant ratio is timesing by 2. So then going backwards, we'd have to divide, right? 1 divided by 2 would give us 1/2, because 1/2 times 2 equals 1. So that's our starting, so I go a sub n equals our a sub 0, right? Our zero term, 1/2 times our ratio, 2 to the n. And that's what we need. Okay, number 2, same idea. Okay, now this one looks a little crazy. So first term, second, third, fourth. Notice that we're going from positive to negative, so our constant ratio is going to be a negative number. That's the only way that works. And we're going from 10 to 2, 2 to 2/5, and then to negative 2 25ths. So to get from 10 down to 2, we're going to have to divide by 5. Okay, so our common ratio is dividing by negative 5, or because we can't use division in our explicit formulas, we think timesing by negative 1/5. Okay, so going backwards, we times by 5, so it'd be a negative 50. So a sub n equals negative 50 times negative 1/5 to the n. Now, this is why we have to do multiplication. We can't write our equation like this. The reason being because division is at the bottom of a fraction, and it'll actually change what we're doing. It really screws things up. So that's why we have to times by the other stuff, okay? Because it won't work using the division. Alright, so there's our second one. Okay, third one. So the zero term first, second, third, fourth, 5 to 15 to 45, we're timesing by 3. So it'd be 5 divided by 3 for our start number. Okay, and remember, for explicit, we're connecting the input here to the outputs. And if we think about, we start at 5/3, that's just 5/3, right? We're timesing by 3, that's our constant ratio. So to get to that should have been 0. The first number in our sequence, 5/3, how does it become 5? Well, we times by 3. Okay. The second, how did it become 15? Well, we took 5/3 times 3 times 3. How did it become 45? 5/3 times 3 times 3 times 3. So we keep multiplying that. And then in our shortcut, okay, that's 5/3 times 3 to the first. That's 5/3. Repeated multiplication is power times 3 squared. 5/3 times 3 cubed. So we see this number right here corresponds with the inputs. Because explicit connects inputs and outputs, okay, we essentially end up with that shortcut, and that connects our inputs. Okay, so a sub n equals 5/3 times 3 to the n. Alright, number 4. Do the same thing. Okay, first term, second, third term, fourth term, zero term. 320 down to 80, 80 down to 20, 20 down to 5. So I'm thinking this is division. So 20 to 5, I divide by a negative 4, right? positive 20. Is 80 divided by 420? Yeah, so 320 divided by 4 would be negative 80. So, if we're going backwards, right, we need to go 320 times negative 4 to get our start number. So it would be negative 1,280. So then we go a sub n equals our starting number times, now remember, because we're not doing division, we change that into multiplying by a fraction to the n. Alright? So there's those ones for the first four. Now, alright, so now on 5 and 6, they've given us the arithmetic. Okay, remember that format? Not arithmetic, the recursive, right? The recursive formula connects outputs to outputs. So this is an output, and this is an output. That's like the next output. So if you're on a table, and you know these numbers, and you're looking for the next number, right, the third term, you'd say to get this next number, a sub n, it's equal to a sub n minus 1, which is the previous output. Okay, so it's like a sub 3 equals a sub 3 minus 1, which is a sub 2, which is this second term. Okay, and then you apply the pattern, which is multiplying by 3. So that's the first part of that formula. The other part you need is you need a starting point. So a sub 1. Now we normally like a sub 0 instead, because that works for our explicit formulas better. But this tells us that first term, okay, a place to start, and they want the first 5 terms. So we start with negative 1, and get our next, and our next, till we get 5 total terms, right? And the constant ratio is 3. So we're times them by 3. So negative 1 times 3, negative 3. Times that by 3, negative 9. Negative 27, and negative 81. So those ones are pretty simple, right? Okay, and that's how easy, and that's dealing with just the outputs, right? Not the inputs, just the outputs. So to get the next term, we take the previous term and we're times them by 1/4, which remember, times them by a fourth is the same as dividing by 4. So you can treat it either way. And our first number, 216. So we find the rest. So 216 divided by 4 would be, that goes 5, that would be 20, that would be 16, so 54. Okay, right? Okay, now we take 54 and divide that by 4, which that gives us, you know, if you wrote it 54 over 4, you could divide that by going 27 over 2. Okay, so we could write 27 over 2, or we could write 13.5. You guys probably prefer the 13.5. We divide that by 4, and we get 3.375. Divide that by 4, and we get 0.84375. If we did it fraction-wise, this would be 27 over 2, which dividing that by 4 would be 27 over 8. Okay, and then 27 over 16. So either one gives you the same information. Alright, now we got 4 story problems. Let's see what they want us to do here. So number 7, Jade is training for a marathon. During her first week of training, each run she completes is 90 minutes long. She increases the length of each run by 10% each week. Write the explicit formula to represent the length of her run after n weeks. Okay, so they're dealing with 10%, so that's 0.10. Right? So, if we're thinking about this, okay, when she starts out her first week of training, she's running 90. However, if we just times by 10%, 0.10, that gives us a smaller number, okay? So the way we have to think about this is for 90 minutes, that's 100%. So we're increasing that by 10%, okay? So it's really 110% that we're timesing by, or 1.1. So that's our constant ratio is 1.1. Okay, so we want to write the explicit formula to represent the length of her run after n weeks. Okay? So what we need to do is we need to go backwards and find the 0 term, right? That's what we need to figure out. Okay, so to do that, we'd go 90 divided by 1.1. And if we do that, we get, and that's supposed to be divided, not plus, we get about 81.8, okay? So then I go a sub n equals my star 81.8 times my rate 1.1 to the n. And that's all we needed to do on that one, okay? So number 8 says you open a savings account with $500 that you have saved. The bank offers 3.2% simple interest each year. How much money will you have in your account after 7 years? Okay, so once again we can make a table. We say we opened it with 500. So that's actually like the 0 term, okay? Because they haven't started applying anything. So each year it's growing by 3.2%. But once again, that 500 is like 100%. So that is growing by 3.2, so it's really growing by 103.2%. So move the decimal or times them by 1.032. Okay, so a few different ways we can deal with this. We can go down and just multiply till we get to 7. Okay, or we can make our formula and use that. So we go a sub n equals 500 times 1.032 to the n. But we want to know after 7 years, so we go a sub 7 equals 500 times 1.032 to the 7th. And then we take a calculator and we figure that out. And we would end up with 623.34 cents. That's how much money we have in our account after 7 years. So we earned $123 just by leaving our money in the bank. Not too bad. Once again, we could have taken this number, times it by that, got the next number, times it by that, and you'd end up with the same thing. So you can use either a table or a formula to help you figure that out. Formula is probably easier, quicker. I shouldn't say easier, but quicker. Okay? So let's take a look at the next. Number 9. Nigel is participating in a readathon. The number of pages he reads each night follows a geometric sequence. On the second day of the readathon, Nigel read 8 pages. On the 5th day, he read 64. Write a formula. Okay, so they're trying to throw us a curveball here. So on the 5th day, it was 64. On the second day, it was 8. Okay, we need to get back to this number, and we need to find out what the growth is so that we can write our formula, right? Because it's a sub 0 times r to the n. So we go from 8 and then 64. 8 times something, times something, times something. Okay? So the way to really do this is kind of difficult. Because you would say, well, we're timesing a number by 3. So if I go 64 divided by 8, okay, 64 divided by 8 equals 8. But that 8 has to be split up into the same number that would be times by itself 3 times. Well, in math, to find that number, we take what's called the cube root, because we want 3 of those. The cube root of 8 ends up being 2, because 2 times 2 times 2 equals 8. So if we times by 2 each time, we can check ourselves. 8 times 2 is 16, times 2 is 32, times 2 is 64. Okay? The way that you guys would probably figure it out is just by guessing and checking. First you times by 2, see if it works. If not, then times by 3, then times by 4, then times by 5. But this is the process that I just did for you, how it really works. So working backwards, that would be 4, and that would be 2. So for our formula, we start with 2, we multiply by 2, and number of times. Okay, last one, number 10. Mr. Galloway purchased a car for $20,000. The car retains 85% of its value each year. How much will the car be worth in 5 years? So we start out, that's how much he purchased it for. Each year, It's retaining 85%, so it's like we times by 0.85. So we can do it this way, right? Where we would just take 20,000 to start off times by 0.85, and that would give us 17,000 after the first year. Times by 0.85, we get 14,450, then 12,282.50. Fourth year, 10,044.440.10. Then the fifth year, 8,874.11. Okay, so we don't even need to do a formula necessarily to do this. However, if we wanted to, we take our start number, 20,000, times it by that growth ratio, the constant ratio, to the n. And for 5, we'd go a sub 5 equals 20,000 times 0.85 to the fifth, which if we type that in, we end up with the same exact number. And there we go, guys.